Hello students, I am Dr. Tanmoy Biswas. I welcome you all in my channel TanmoyChem. Today's topic of discussion is one MCQ and the question is in front of you. I request everyone, please pause the video, try by yourself. Whatever answer you get, please write in the comment box along with few words as your explanation. I believe you have tried, so let's start. Now, student, if you read this question, how many transition states and intermediate produced during the course of this reaction? So it's a number of transition states and intermediates. So remember, this question is actually a mechanism based question. So you should remember mechanism of some reaction, otherwise you may miss this. So for that purpose, I suggest please read this part. Protonation of alkene to prepare alcohol. Actually, in this way, the end product is alcohol. I've already discussed. There's some dedicated lectures on this topic. Please visit if you want to know further. But here I shall solve it in a different manner. First, I shall explain the mechanism. Later on, I'll give a tricks. So let's go. So how this reaction is happening? Since it's a mechanism based question, let's learn the mechanism first. So first, H plus is given. Remember, alkene is actually an electron rich molecule. So these alkene will act as base, and H plus obviously is given. By the way, water H plus, you may confuse, sir, is it really possible free H plus exists? No, it will remain as H3O plus, but question can come in any way, so that's why you should remember. Now if you say this alkene, this is actually a neutral molecule. Since it's a neutral, it's getting attached to an H plus, so what will happen? A net positive charge. How reaction takes place? So this proton is abstracted by this double bond. Now if you look at here, this carbocation is actually secondary, means the hydrogen get attached to this carbon. Now if you ask me, sir, why not the opposite? Then the resultant carbocation is expected to be the primary. What do I mean? So hydrogen attached here and the carbocation is here. Remember, primary carbocation is obviously less stable compared to the secondary one. So carbocation stability order is tertiary greater than secondary greater than primary greater than methyl cation. Student, remember, very often people do not remember the last point. Okay, fine. Now in this way, if I ask you how it's stabilized, so you can say there are 3 hydrogens here, so 3 alpha hydrogen this side, and here if I say next it's a quaternary carbon, so no alpha hydrogen, total 3 alpha hydrogen. But if you look at primary cation, so they are actually 2 alpha hydrogen, and by the way 2 plus I effect works here only 1 plus I effect works. So from that point this carbocation is more stabilized because of 2 point. One is hyperconjugation, means alpha number of alpha hydrogen, and second number of plus I effect. Now this much you understand. Step 2, what happened? Step 2 actually rearrangement reaction. So this is a 4-member ring. We know 4-member ring has some ring strength. It tries to relieve the ring strength. So if possible, it can undergo 1-2 migration. So because of these 1-2 migration, ring size increases, which may result in reduction of ring strength. So what can happen? These will go there. Now student, I'll show you one tricks to draw, because I have seen many students do mistake when they draw such kind of structure. Okay, so here draw everything as it is. Just change the bond which is broken. So here the bond broken, and that since this bond pair migrated, okay, this carbon migrated with the bond pair, so positive charge or electron deficiency will come on this carbon. This is now next phase, draw exactly. That is far more better. So actually you may consider it's a 1,2 dimethyl cyclopentyl cation. Now next phase, it's a carbocation. Now if you look at this carbocation, this carbon has 3 bonds with these 3, although you can say, sir, it is tertiary. Fine, and tertiary means it is relatively more stable. Why? 3 plus I effect. Not only that, here 3 alpha hydrogen, here if you look at 1 alpha hydrogen, here 2 alpha hydrogen, so total 6 hyperconjugation possible. Not only that, if you look at what is the driving force from this step number 2, the logic is that from 4-member ring to 5-member ring, so relief of ring strength, point number 1. Second point, so in this case it was a secondary carbocation, here it's a tertiary carbocation, so it is relatively more stable. Now this much I guess you have understood. So now it's now if you say further rearrangement possible, answer is no. Not further ring expansion possible, because already tertiary carbocation is got here. Next phase, what happened? This water will attack to the carbocation. Why? Now if you look at this carbon atom is attached with 1 carbon, it has 3 bonds. So 2 electron here, 2 electron here, 2 electrons. So total 6 electrons surrounding this carbon center. So it is a 6 electron species incomplete octet molecule. It is actually Lewis acid also, and it has a vacant p orbital. I mean here it's a vacant p orbital which can accept a pair of electrons. So remember, carbocations are nothing but Lewis acid, and here the water molecule is acting as Lewis base, means it will attack with its lone pair there. Okay, so addition takes place. Now if you look at water molecule, so it is actually a neutral molecule. Oxygen gave its electron density to carbon atom which was deficient. So obviously oxygen will have a deficiency which is designated by this positive charge. In another logic you can think positive charge plus neutral molecule, so positive charge. But first one I believe more accurate. Now oxygen carrying a positive charge. Remember, oxygen is a pretty high electronegative atom carrying positive charge, not that much stable. So what happened? One H plus is released in step 4, and what it produces? It's a tertiary alcohol with ring expansion. So now if you look at this process, by the way, it is actually a hydration reaction. It is a hydration reaction where catalytic amount of acid is needed for this process. So here if I look at this, is actually step 1, 2, 3, 4, 4 step reaction. And remember, for each step there is one transition state. Now if I say clearly that okay, the first one and the last one, so this is my reactant and this is my product. Okay, so these are actually this intermediate 1, intermediate, so I1, intermediate I2, intermediate 2, here this is intermediate 3. So here it is actually each step they have one transition state. So TS1, TS2, TS3, TS4. So total 4 transition state, 3 intermediates are produced. By the way, all intermediates, these two are carbocation and this one oxygen cation. Now, so what is the answer? Here answer is actually 4 transition state and 3 intermediates. Option B is the right answer because 4 steps. Now before ending up, let's learn little bit a very common example, that is SN1 reaction. We know that in SN1 reaction, first this Rx break down into R plus X minus. In the next phase nucleophile get attached and it produces RNA. So it is a nucleophilic substitution. It's a 2-step reaction, and in this case the carbocation is actually the intermediate. So this is you can consider it's an energy level of intermediate. And by the way, for each step, either step 1 or step 2, individual transition state exists. By the way, I have written wrong. It's a TS2, it's a TS1. Okay, so transition state 1, transition state 2. So remember one thing, if you look at how many steps, so number of steps is equal to the number of transition state. And exactly with respect to 1 unit less, so intermediate will be number of transition state minus 1. So this is the formula, this is the tricks. It will be easier, just remember this. So from there we have clearly understand that 4 transition state, 3 intermediates. Now if this question appear in your exam less than 30 seconds, how can you solve it? First you need to remember one thing, that okay, transition state should be more in number compared to the intermediate. Now 3 transition state, 3 intermediate, it's the invalid option, ignore. Okay, now all our transition state is more compared to the intermediate, fine. Now in the next step you need to go stepwise. I suggest take a pencil and try to think, or think in your brain that okay, first step carbocation formation, second step migration, and third step water addition, and fourth step H plus removal, because catalytic amount of H plus needed. Total 4 step. Okay, so 4 transition state and 3 intermediate. Agree? So this is the discussion, but I believe you should remember this concept, because in exam hall sometimes our brain get choked. We are not able to think, and actually these questions are pretty time consuming question. So practice in such a way that time requirement you can minimize for yourself. So for that purpose, systematic study means more number of study, more number of question practice. That is the only solution. Okay, so this is the overall discussion. I believe this video may be useful. If you really enjoy, then help this channel to grow. And if you have any doubt regarding the logo of my channel, please read this part. Your doubt will be clear. So see you in my next video. Bye bye.